Ladies and gentlemen, can I welcome you here to the Royal Society, and also can I welcome all of those of you who are watching on the internet, wherever you are. And I should begin by saying that my name's Martin Polyakov. I'm the Foreign Secretary of the Society, and Sir Paul Nurse, the President, wishes he could be here and apologizes for his absence. So you'll have to make do with me. And today we're here for the Michael Faraday Prize. And this is the UK's foremost award for excellence in communicating science to the public. And this year's recipient is a very worthy person to get it, and I hope you will judge this from the lecture. The lecturer is Colin Pillinger, CBE, FRS, who was the founder and first head of the Planetary and Space Sciences Research Institute at the Open University. He studied at the University of Swansea chemistry as an undergraduate, followed by a PhD in mass spectrometry, and in 1984 he was awarded a Doctor of Science in chemistry by the University of Bristol. I'm sure you didn't expect to be addressed by a chemist here. Colin has received medals and awards from a number of learned bodies, including the British Mass Spectrometry Society and the British Interplanetary Society. He's been elected Fellow of prestigious institutions, including the Royal Society, the Royal Astronomical Society, and the Royal Geographical Society. Colin is probably best known as the leader of the Beagle Project, the attempt to land a British-built spacecraft on Mars in Christmas Day 2003, to search for evidence of life on the Red Planet. But it's much less well known that he's been involved in space exploration for over 40 years, beginning with the NASA Apollo program in 1968. And throughout this time, he's shared his experience with the public through frequent lectures, exhibitions, newspaper articles, books, radio, TV interviews, which marks him out altogether as one of our country's leading communicators of science. So it now gives me great pleasure to invite you, Colin, to deliver the Michael Faraday Prize Lecture, Stones from the Sky. But before he does, first of all, I must remind you to switch off your mobile phones. And secondly, and more importantly, I must present you with a medal and prize. It comes in three parts. So, first of all, there is the medal, gold medal, certificate, and perhaps most desirable, the cheque. So now it's over to you.
It's very dangerous, Mr. Chairman, giving the speaker the cheque before he's delivered the lecture. Well, thank you very much for the introduction, but most of all, thank you to the Royal Society for allowing me to address you this evening. I like talking to people about science. I particularly like talking about meteorites because meteorites, stones from the sky, they give me an opportunity to tell people anecdotes, and then when I've got them listening to me, I slip a little bit of science in when they're not quite expecting it. And I think my favorite audiences are audiences that don't know they're interested in science, so you have to sort of put a little bit of sugar on the pill to make them, you know, they get it without being aware that they're being told about something, which has excited me for many years and has, you know, given me the opportunity to do so many things that I wouldn't have been able to do if I hadn't become interested in science. And science is such great fun because it's like Christmas all the time. There are always surprises that you don't know what you're going to get. You don't know what to expect, and you'll always find out, many more things than you set out to discover when you do the experiment. And it's afforded me a marvelous life, and I thank everybody for, helping me to be able to enjoy that. In the very first going off, as soon as I agreed to give this lecture, I began to look for a slide to go with the title, and I immediately found something which I didn't know, so that was the first surprise to me. I knew about this picture, which is the picture of the Enzian meteorite fall in Alsace in France. It was painted in 1492 by, or around 1492. I don't think it was actually painted that year, but it was painted by an up-and-coming young artist called Albrecht Dürer. He didn't have very much money, obviously, to buy canvas, so he painted it on the back of a portrait of St. Jerome that he did. That painting was hidden away for many years. It was in a private collection and had been loaned to the Fitzwilliam Museum in Cambridge. And when I started to research this lecture, I found that it had actually been sold to the National Gallery. So anybody wishing to see it can now go down to the National Gallery and see this very unusual painting, and as I say, very historical painting. The first meteorite fall recorded in Europe. Meteorites became, the Royal Society didn't become aware of meteorites till a lot later. In fact, there's a distinction between meteorites and meteors. Meteorites are the stones once they reach the surface of the planet. If you just see the flash of light going across the sky, it's still only a meteor at that time. And in 1793, there was a rather famous meteor appearance, a daylight meteor. And I show you this painting here from contemporary painting by Paul Sandby. It caused quite a lot of correspondence to the Royal Society from various fellows who actually saw it all over Britain. So it was a very major event. We had to move on in 10 years before another fellow of the Royal Society got involved in a meteorite fall. This is a fellow called Frederick Augustus Hervey. He was also the Earl of Bristol and the Bishop of Derry. There's a lovely little anecdote about this gentleman. If anybody's ever wondered when they're traveling around on the continent why every town seems to have a Hotel Bristol, it's because this man stayed there. Not specifically at the hotel, but he visited the town. He was an inveterate traveler, and he was traveling in Italy in 1793 when a shower of stones fell in the town of Siena. He got one, packed it up, and he got it conveyed to the then president of the Royal Society, Sir Joseph Banks. In those days, people didn't believe anything about meteorites. If you told someone you'd seen a meteorite or had a meteorite, you were considered to be a very ignorant peasant, very gullible, the sort of person who would answer an email from Nigeria saying that someone had left you several £1 million. And anyway, Sir Joseph, on receipt of this meteorite from Augustus Harvey, packed it up and sent it back to Italy and sent it to the ambassador to the court of Naples, Sir William Hamilton, with a message saying, I think the odd bishop is a teller of tall tales. Sir William agreed. Sir William was much more interested in the geology of volcanoes, so he sent back a message to the president saying, I think this rock was something which shot out of Vesuvius. So, meteorites, the science of meteorites hadn't been born by the intervention of Augustus Hervey. Something else about Sir William Hamilton is that he had a nephew, Charles Francis Greville, also a fellow of the Royal Society. Charles Francis Greville was a collector of geological curios. He collected meteorites. He had quite a substantial collection of meteorites. In fact, his collection formed the basis of the Natural History Museum's collection. About this time, however, Mr. Greville was a little bit hard up, and he needed his debts paid. So he asked Uncle William to meet his debts, and in return he swapped his Uncle William his mistress, a lady called Emma Lyon, who became better known as Emma Lady Hamilton. And of course, Emma Lady Hamilton swapped Sir William for Horatio Nelson. And of course, we all know what happened. Horatio won the Battle of Trafalgar, and who knows, it must have been all to do with the Sienna meteorite. It's a nice story. It gets people interested, and then you can slip something in about the meteorites, you see. Anyway, there's out in the hall, I don't know if any of you noticed, but in one of the display cabinets at the top of the stairs is a book by a man called Edward King. It's the first book in English written about meteorites. He too was a fellow, and he was writing at the beginning of the 1790s about meteorites said to have fallen from the sky. In fact, he used my title. He obviously preempted me by over 200 years. At the same time, however, there was a German gentleman called Ernst Chladni, who was a research student of the man on the right of the picture, George Lichtenberg. And Lichtenberg told him to go and study these phenomena that were falling from the sky. So Mr. Chladni went away and duly scanned the literature, and this is a word of caution to all research students, if there are any in the audience. Chladni went away, scanned the literature, did some very nice research, wrote a nice book about stones having fallen from the sky being meteorites, and went back to his supervisor, Lichtenberg, and told him what he'd done, gave him a copy of the thesis. Lichtenberg read it and he apparently exclaimed, "I felt as though I had been hit on the head by one of Chladni's stones." So he persuaded Chladni not to do any more work in this area, persuaded him to go off and do something on acoustics. Now, Chladni is actually famous for his figures. He invented a number of musical instruments, and nothing more would have been known about his involvement in meteorites until somebody unearthed all this work 200 years later. Anyway, we're still in the late 1790s. This is another depiction of the Ensisheim meteorite fall, and you can see that it's a picture of some agricultural workers. Agricultural workers have always been very prominent in the discovery of meteorites. These people who drive tractors or horses up and down fields have nothing better to do, and actually unearth some very interesting pieces of stone in their fields, or see some very interesting falls that they, fortunately for us scientists, pick up and bring in and give us to do our work with. There was a young man, a 16-year-old young man, called John Shipley, working in a field. He'd actually gone to tend some sheep in a field in 1795 when a meteorite landed no more than 8 meters away from him. John Shipley, he was very lucky not to have been killed by that meteorite because it was 56 pounds in weight. He lived another 30-odd years, but he has a very interesting tombstone to the memory of John Shipley, who departed this life May 17th, 1829. And the epitaph says, "All you that do behold my stone, oh, think how quickly I was gone. Death does not always warning give, so be careful how you live." Now, whether he was referring to just a general philosophy or for his survival from the meteorite fall of the Wold Cottage meteorite, I have no idea, but it makes a lovely story. John Shipley collected this story. His employer collected the meteorite, the so-called Wold Cottage meteorite, and interrogated both John Shipley and all the other people who worked on his estate in Yorkshire, and he came to the conclusion that they were all telling the truth. And the man who owned the estate was a man called Major Topham. This is a caricature of Major Topham, because Major Topham was a very famous man in the late 1790s. He came to fame because he was the man who led the charge of the Horse Guards against the riot in Palace Yard at Westminster when we almost had the British Revolution, when Parliament was trapped in Parliament by a mob of 60,000 people. Topham was the man who led the charge of a few cavalry officers to disperse 60,000 rioting peasants who had been taken there by Lord George Gordon. So he became a very famous man. He then had the most illustrious career that you can possibly imagine. He became the proprietor of a newspaper. It was the newspaper that was the equivalent of the Sun of its times. He told the sort of stories that people wanted to read and interspersed it with a little bit of the news. He was a founder of the Royal Veterinary College. He raced greyhounds. He was involved in the theatre. He, in fact, his consort was a lady who was the most famous comic actress of her day, who bore him 3 children. So Mr. Topham was the perfect person for a meteorite to land on his property, because Mr. Topham liked to make, he was a real PR genius. He liked to make the most of any story that came his way. And there's a picture of Major Topham. There's another of the caricatures of him. And you see above it a prospectus for the World. The World was his newspaper. That was the newspaper he founded. And the very pregnant-looking lady in the background was this actress that he was the love of his life, a lady called Mrs. Wells. Here's a picture of Mrs. Wells and her 3 children, Juliet, Harriet, and Maria Cowslip were their names. The middle of those children, Harriet, actually drew the Wold Cottage meteorite. Here's the picture that she drew. She was probably about 10 at the time, and she put on the picture the measurements, both the dimensions and the weight. Topham he took his picture of the meteorite, and he published about it in the newspapers. This is an excerpt from the Times that he published, and he put the meteorite and the picture on display and invited the public to pay a shilling to come in and see it. And he displayed it just up in Piccadilly, not, a stone's throw from here, shall we say. And this is the scene of outside the so-called Gloucester Coffee House, where Mr. Topham took the meteorite and began to proclaim to the public that this was a stone from the sky. It must be something that was scientifically interesting. He also recorded the event by erecting a pillar on the spot where it fell in Yorkshire, near his mansion, which was idiosyncratically called the Walled Cottage. I assure you it was not a cottage, but the man was pretty much idiosyncratic everywhere you went. He called his totally black greyhound Snowball, for example. So, but he was the man who made the news. He was the news. He made it. He reported it. This is a contemporary portrait of him on the left, and he was sitting for that portrait at exactly the same time as the gentleman on the right, who was the president of the Royal Society, Sir Joseph Banks. And so they must have come across each other. They must have met, and Banks must have been convinced that here was something that needed to be investigated, because he instigated a study of meteorites by this gentleman here, another fellow, Charles Edward Howard. And I'm sorry about the poor quality of this picture, but it's the only one that I know of that exists of Charles Edward Howard. Anybody who wants to find me one and present it to the Society, I'm sure they'd be most grateful, because he was the recipient of the Society's, one of the Society's premier medals, the Copley Medal. And he did the study that Sir Joseph commissioned on a number of meteorites, and there was such interest in this study that the discussion meeting for the Society, which took place every week, actually overran 3 weeks. It went on for three consecutive weeks. They talked about the fact that stones had fallen from the sky. And the work that Howard did was to demonstrate that these were all these rocks that had been fallen all over the world in different places, that they'd accumulated together through Greville and Banks and Sir William Hamilton and King and so on and so forth. They had a great similarity. They all had metallic iron in them, and that metallic iron was contaminated with nickel. And terrestrial iron metal is not contaminated with nickel. So the work that Howard did proved that the meteorites were related. They must have come from a common source, had to be outside the Earth for them to have fallen from the sky. And so this was the fundamental piece of work that made people take notice of meteorites. So it was the subject of a 3-week lecture by Howard here, and Edward Topham and his friends are to be thanked for precipitating that work. A sad picture, however. I went in search of Howard's gravestone. Howard was interested in sugar refining as well as analysing geological materials, and he was killed in an explosion. He invented actually mercury, or he discovered mercury fulminate, the detonator, and he was blown up. I couldn't find his grave because, unfortunately, all the graves where he was buried in St Pancras churchyard were removed in order to make the railway station. And here are all the gravestones gathered together in a corner. And somewhere amongst those gravestones is Charles Edward Howard, who clearly wasn't careful how he lived. Otherwise, he wouldn't be in that corner of St Pancras churchyard. Another anecdote about this is that the person who put those stones there was Thomas Hardy of Tesla d'Urberville's fame. He was the engineer in charge of the project. Right, okay, moving on. Because of the work that Howard did and because of the interest fostered by Topham, people now began to accept that stones from the sky were meteorites. Not immediately. They certainly weren't accepted immediately in France or in America, but fortunately the prejudice was overturned, and a meteorite that fell in 1815, this tiny village in France called Chassigny. Actually, the spot is commemorated by the fact that the road is now called the Le Chemin de la Meteorite. This meteorite that fell there, Chassigny, was the first of a small group of meteorites which for many years were called SNC meteorites, after the type names of the specimens that had been collected. It turned out in the early part of the 1980s that this small group, and this particular meteorite, Chassigny, was one of a small family of what we now call Martian meteorites. And another very interesting Martian meteorite fell in Egypt in 1911 when it is supposed to have killed a dog, although I think that's probably an apocryphal story. The Dhokla Meteorite was one that we analysed at the Open University and discovered in it the mineral, the aqueous mineral carbonate. And there's a lovely picture we have of the Pope examining the Dhokla Meteorite. The fact that this mineral was present in Dhokla suggested to us that water was actually prevalent on Mars, which turned out to be, it turned out to be very controversial when we suggested it. It took a long time to persuade people that in fact was true, because the kind of rock this is shouldn't have an aqueous mineral in it. When another rock of the Martian meteorite clan was found in the early 1990s, that had a great abundance of this mineral carbonate, people began to take carbonates much more seriously in meteorites. And then when a sample of the carbonate from this meteorite called Allen Hills 84001 was demonstrated to have what was believed to be a fossil in it, then, as you can imagine, the news media went absolutely ballistic. And this particular study was the subject of a press conference which was introduced and opened by President Clinton. And the BBC had me standing in reserve waiting for President Clinton to stop speaking so that they could drag me in front of a camera. It's the only time in my life I've had a president as a warm-up act. This is very controversial, but much of the evidence is still as good now as it was when it was first reported in 1996, particularly the fact that associated with these features in this rock is a mineral called magnetite, which is a biological mineral. The outcome of this particular study here was that the rock was over 4 billion years old. The logical conclusion of what was being seen here was there life on Mars 4 billion years ago? Well, that is kind of acceptable because life appears to have originated on Earth about 4 billion years ago. But in the wake of this particular study, we had a meeting at the Royal Society where we reminded people that we had analyzed another one of these Martian meteorites, one which was much younger, only 180 million years old, that had left Mars, had been dated as leaving Mars 700,000 years ago, and had arrived on Earth 13,000 years ago. That particular rock has in it, associated with the carbonates, it has organic matter, which if you work on terrestrial rocks, you would say it's organic matter which is a chemical fossil as opposed to a fossil of a living organism. And chemical fossils are much they're much easier in a way to study because you can study them with analytical techniques and instruments, whereas fossils have to be seen by somebody, and then a fossil becomes a question of whether the eye interprets what it wants to interpret. But it's much more difficult to fool a machine. So this particular rock had organic matter in it, which we could argue was associated with the carbonates and seemed to be evidence of life on Mars much more recently. More recently in the sense of now, because 700,000 years ago, hominids were walking around on Earth. It could be telling us that life on Mars is contemporary. As I've said, both of these findings were very, very contentious. If you want to make something as extraordinary as claiming you've discovered life elsewhere in the universe, you have to have pretty extraordinary evidence. And people didn't want to believe this evidence, and so we resolved that we would end the controversy by sending the Beagle 2 mission to Mars to repeat the experiments that we'd done on this meteorite 79001. And that was why Beagle 2 actually was born, is that people didn't believe what we'd said in the early 1990s, so we decided we would go back to Mars and do the experiment again in a way in which they couldn't argue that we'd been investigating terrestrial Earth's contamination. So, sorry, we built this, I had this tremendous experience of leading a group of people who were among the best people I've ever been my privilege to work with, to put together this tiny package of instruments to take it to a planet when nobody actually wanted to pay for it. It was such an amazing experience to have people who wanted to work for you for nothing and would do anything that you asked them because they thought that the cause that you were espousing was just something that they wanted to be involved in. And what we achieved was actually to shrink a room full of equipment into a device about 5.5 kilograms, the size of a shoebox. It could do the work of 4 mass spectrometers, and in order to get that to Mars, we built a spacecraft that weighed only 32 had a mass of 32 kilograms, and it had an entry, descent, and landing system, which was a little bit more, about 35 kilograms. And we launched it to Mars on June the 2nd, 2003, and it was supposed to land on Christmas morning, as we've already heard, 2003, but unfortunately it never sent us a message. And if you want to know the full story of that, you have to read my autobiography. I'm not going to say any more. I'm going to go back to British meteorites for the last part of the talk. In the 200 years since Wold Cottage was recognized as a meteorite, we've had something like a meteorite every sort of 15 to 20 years. The last one seen to fall was in 1991, which is now just over 20 years ago. So we're due another British meteorite any day. I already said that farm labourers have done a very good job in collecting meteorites for us. Here's another picture of a farm labourer who was collected the nearest meteorite, I think, to fall nearest to the Royal Society. It fell in Ashton in Essex in 1923, and it was seen by one Frederick Pratt. I've been able to trace what happened to Frederick Pratt. I'd love to know what happened to him. But what I do know is when a stone landed near him in a field in Essex, what could he think to do? Well, first of all, he told the policeman, the local bobby on his bike, and he told the local vicar. But I've never been able to trace what happened to Frederick Pratt after, which one day I will know. Back before that, this is a very interesting meteorite that landed in a railway siding near Middlesbrough. The men who found this told their foreman. The foreman told it to the railway company, and the railway company asked Alexander Herschel to come and investigate it. He was the grandson of Herschel, the famous astronomer. But I'm now going to jump back many, many, many years to a meteorite that is all of those meteorites that I've just talked about are what we call falls. In other words, in Britain, most of the meteorites we have been seen to fall. It's very unusual to find a meteorite, and they are called unimaginatively. If it's not seen to fall, but you pick it up and recognize it as a meteorite afterwards, you call it a find. Very few finds exist because our climate is such that the meteorites are weathered away rather easily. The first and well-authenticated find of a meteorite that we have in Britain came from the Iron Age fort of Danebury Hill in Hampshire. It was recognized as being a meteorite. It wasn't collected as a meteorite. It was recognized by a technician who was given a whole box of what were thought to be Iron Age artifacts, bits of smelt that he was told to investigate to see whether or not he could learn anything about the processes that were being used by these Iron Age men. But he was smart enough to notice that he had some iron which had nickel in it and recognized that he had a meteorite in his possession. This was in the 1970s. He then promptly lost it. And it took us several years to have Oxford, where he was working, rediscovered it. It was apparently in his office, which was a little bit like my office. If you wanted to go in it, you had to take something out of it in order to make space for the person. But anyway, this meteorite that has the name Danebury, the meteorites incidentally are named after the places near to where they fall. And so this one's named Danebury after this hill fort. Danebury was very extensively excavated in the 1970s. It's a very well-known archaeological site. The holes that you see here are not randomly dug holes. They're holes that were dug that were either post holes there for the dwellings there, or they were holes that were used to store grain. The Iron Age hill forts were actually built in order to, the people were becoming farmers, And the forts were built in order to protect their crops that they'd gathered so that they could survive through the winter and that they could keep their seed in order to grow a new crop the following year. These holes that you see here, many of them are dug in the chalk of Danebury Hill, and they were used to store grain. It was in one of those so-called grain pits that the Danebury Meteorite was found. And what happened with a grain pit is a hole would be dug a couple of meters deep. It would be filled up with grain, and then it would be capped off with bits of chalk and clay. And the grain would survive in that. The environment would become anaerobic, and the grain would survive. Coincidentally, it's a perfect scenario for the meteorite to also survive. And the Danebury Meteorite was discovered and dug out of one of these so-called grain pits. And it probably had got in there, not during the time the pit was in use for storage of grain, but in the couple of years after the pit became redundant and was then filled up by digging the next pit to it. So the pit would be, you wanted to get a new, nice anaerobic pit, so you'd fill up, dig a new hole, put the spoil into the one that you didn't want to use anymore. And the Danebury Meteorite was found close to the top of this particular hole. And it appears that Danebury Meteorite survived away from weathering because of the anaerobic conditions caused by, the situation in which it was either fell or placed. Now, that would give us a very nice clue for something else. Here is Danebury itself. It's a tiny meteorite. It was only 32 grams. You can see in the central picture there, it's got lots of pure metal iron in there, which it means that the sample was very non-oxidizing because the iron didn't decay away to rust and the meteorite didn't fall apart. You see on the outside of the meteorite, there's bits of the adhering chalk that probably helped to create those anaerobic conditions. But that meteorite was excavated from that pit, and everything that came out of that pit was located with 1 centimeter accuracy. So that's probably the best, most accurately documented meteorite find of all time. But something about Danebury led us on to something which we found much more fun. Danebury, as I've said, was a fort. It's something that fell. We've dated it at just over 2,000 years ago, when the fort was a very active place during the Iron Age before the Roman invasion. When we were working on Danebury, I remembered something that had occurred 20-odd years ago of a man bringing a meteorite into the Natural History Museum, which actually came from a place 20 kilometers away from Danebury. And having found this very small meteorite, that we called Danebury, I suddenly thought, well, maybe this meteorite that had been brought in from 20 kilometers away was part of the same fall. Something worth investigating to look at to see if we had 2 meteorites that fell in the Iron Age. And so we began the search for a meteorite which has become known as the Lake House meteorite, because Lake House was the place where it came from. It was brought into the Natural History Museum by a man who described it to the curator there as Grandfather's Stone. It was a story he told was not very consistent, and so having identified the stone that came in as a meteorite, the curator did nothing more about it. He just dismissed it as possibly a meteorite that might have come into Grandfather's possession from somewhere else, maybe not from the place where the meteorite was actually, where the man who brought it in has said it came from. So it was forgotten about until we decided that we'd resurrect this story and see if we could find out more about the mystery of Grandfather's Stone. And the reason why we wanted to find out about the mystery of Grandfather's Stone, no Having located it in the Natural History Museum store, we were rather shocked to find it was 93 kilograms. That makes it a very big meteorite. In fact, that would make it about the 4th or 5th biggest intact so-called ordinary chondrite in the world's collections. They're very fragile, these things. They you know, as I've already said, they weather away and they break up. The other exciting thing we found about it was that we thought, well, we know the age of the Danebury stone. We better find out to see whether or not the age of the big one is the same, in which case it's the same fall. So when we measured the terrestrial age of it, we were shocked to find it was over 30,000 years old. Now that immediately says to you, you have to have this meteorite in a place which is going to be conducive to it surviving 30,000 years. You can't expect a meteorite just to fall in your back garden and be there 30,000 years afterwards. So this became an intriguing sample. We thought we'd better find out who Grandfather was and where Grandfather might have got this stone. Grandfather turned out to be a Lieutenant Colonel F.G.G. Bailey. He was a man with a long military career who had begun his soldiering in the Boer War. He'd been a prisoner of war in the Boer War. He fought all the way through the 1914 war. Seemed to be have a charmed life. Other people. He started out as a low, ordinary ranked officer, but everybody near him seemed to get killed, so he kept getting promoted, and he ended up as Lieutenant Colonel. Here's a picture of Lieutenant Colonel F.G.G. Bailey of Lake House. So we thought we'd better investigate Lake House itself. And there was a long, having interviewed members of the family, we found there was a long tradition for as long as anybody can remember. Grandfather's stone was on the steps, not on the steps, by the steps of Lake House. And we managed to unearth a 1960s photograph showing Lake House, the Lake House meteorite alongside the step of Lake House. Then we managed to find another picture back to 1937. We were tracing the stone back. F.G.G. Bailey lived in Lake House since in the 1920s. So his stone had obviously, wherever he got it from, it had pride of place at his house for some, at least sort of 60, 70 years. Then we found that there was another photograph from 1908. Now the importance of this is that Grandfather, whatever Grandfather's stone was, Grandfather wasn't there in 1908. He was actually in the army. At that time he was possibly serving in the Middle East, although he certainly didn't live at Lake House and lived in barracks somewhere. So Grandfather's stone wasn't actually Grandfather's stone at all. It was the Lake House stone. Any idea that this was something that Grandfather might have collected on his travels and brought back to Lake we could now dismiss. And just to be sure about this, we found another angle from the same year of the stone, no longer by the steps, but on the step. Now, this is a rather famous country house, and I don't know about you in the audience, but if I took a big stone like that and put it outside the front door, my wife would have told me, get rid of that something stone before somebody trips over it. That leads us to believe that stone would only just been put there recently during the period around 1908. It possibly was a stone that was in the house and was brought out and put on the step. Might even have been put there for the photograph. Now the researchers had to turn to who lived in the house before F.G.G. Bailey. Well, we searched and found that Bailey bought it from Lord Glenconner's widow, a lady called Lady Grey. Incidentally, the Glenconners are the people who owned the island of Mystique in the West Indies, where Princess Margaret used to like to go and stay. Lord Glenconner had actually purchased this in 1918 from a man called Joseph Lovibond when Joseph Lovibond died. I'll tell you more about Mr. Lovibond in a minute. And Mr. Lovibond acquired it from a man called the Reverend Edward Duke, and more about the Dukes later. All of these people, particularly F.G.G. Bailey, knew a fellow of the Royal Society, a man called Oliver Lodge. I'll tell you more about him as well in a minute. So who was Joseph Lovibond? Joseph Lovibond was a brewer. He was a scientist who invented a kind of spectrometer that is used to measure the quality of beer, so I immediately liked him an awful lot. He also, as in his early days, had run away from home and became a gold miner. He wasn't a very good gold miner. He did get some gold and made his fortune, and he was about to bring it home to England. And he was sailing across Sydney Harbour when his cap, where he'd put his gold, fell into the Sydney Harbour. So Mr. Lovibond's fortune is somewhere at the bottom of Sydney Harbour for anybody who wants to go and collect it. As I said, he was a brewer, and there's a famous brewery in both Salisbury and in Greenwich that bears the Lovibond name. But he was a scientist. That was the important thing. He was a scientist who could have recognized that he had a meteorite, hence the reason why it was put out on the step. It might have been, he might have known it was a meteorite and therefore could have put it there. But there's better than that to identify this as a meteorite. Sir Oliver Lodge, who was he? Well, he was a very well-known fellow of the Royal Society, physicist, engineer, the man who invented the spark plug that all our engines run on. He was also a pioneer of radio. He gave lectures about meteorites and wrote papers about meteorites. Well, in actual fact, his students wrote the papers and his students wrote the lectures for him to give. Another warning to students here is that don't let your supervisor take all the credit. So Oliver Lodge could most definitely, who was a friend of all these people who lived there before F.G.G. Bailey and Bailey himself, could easily have recognized this stone as a meteorite, and therefore it was something which was well worth keeping and collecting. There's a picture of Oliver Lodge here against the background of one of the triathlons at Stonehenge, because all these people had an interest in stones on Stonehenge. Salisbury Plain was a place where there weren't many stones, and they were all interested in the problem of how Stonehenge got to be where it was. Before Lovibond came the Dukes. There were, I don't know how many generations of Dukes, something like 15 generations of Duke who lived on the Lake Estate. The Duke family acquired it in the 1500s, and the original house was built there in the 1570s. So the Duke family had lived there for 400 years. In the immediate precedence to Lovibond was the surgeon Edward Duke, the antiquarian Reverend Edward Duke, the geologist Reverend Edward Duke, and the vicar Reverend Edward Duke, Helgerford Duke. We ended up trying to distinguish these people because they all fortunately had wives of different names. So we started calling them, Mary and Sarah and so on and so forth. But they were all people who, or two of them were people who could have been very interested in stones and collecting stones. The geologist and the archaeologist. The archaeologist was one of what was called the barrow diggers. The Lake Estate on the Salisbury Plain is a place where there are a great many ancient burial sites. And the Reverend Edward Duke, between 1805 and 1852, excavated 150 burial mounds, along with the help of famous archaeologist Sir Richard Hoeber and his sidekick William Cunnington, and their technicians called the Parkers, father and son, who did all the digging, did the hard work. The Cunnington and or just stood by and watched, and the other guys did all the hard work. All of them were acquainted with the word meteor, not necessarily meteorite, because there's correspondence between those people about the meteor of 1806, which was another very bright meteor, like the one of 1783. So if they came across a stone that was a meteorite, they would have known what it was, and they'd have known to collect it. So our supposition, I now have a hypothesis to put forward to you. I've argued that the stone shouldn't have been there, and shouldn't have been there for 30,000 years unless of very specialized circumstances. Well, Salisbury Plain wasn't always like Salisbury Plain. Over 10,000 years ago, Salisbury Plain was underneath the enormous glacial ice sheet. And there was a glacier coming down the Irish Sea, feeding the glaciers that ran out across Salisbury Plain, which may have reached as far as Stonehenge, but may have fallen just short of Stonehenge. And there are well-known archaeologists and geologists who believe that the stones for the Stonehenge got there because they were the residual deposits of the debris of stones that were carried to Salisbury Plain in the glacier, on the glacier from the Preseli Mountains in South Wales. To connect the reasons why Lake House may have been able to survive the weathering, we noticed on the picture of 1908 that there was a patch of white on this meteorite. And we looked again very closely at the sample as we have now, and we found that there were residual little patches of white, which we scraped bits off, and we identified them using Raman spectroscopy and XRD and measured them with isotopes. And we believe we can match those bits of white on the meteorite to the chalk, which lies around in the fields around Lake and the surrounding areas, including Danebury, as being Upper Cretaceous chalk. So we think there's a good reason for believing that partially the meteorite survived, because it must have been, at some stage in its life, been buried in chalk, like it would have been if it had been buried in a burial mound. So the hypothesis that we've come up with now is that the mystery of Grandfather's Stone is resolved by it being the oldest and biggest British meteorite. It's something that probably landed on a glacier, similar to the meteorites that we now collect many every year from Antarctica, which land on the Antarctic ice sheet, which are able to survive in the frozen ice or on the frozen ice for many thousands of years. So the meteorite originally landed on the ice or on the permafrost. It survived the first probably 20,000 years of its lifetime because of it being frozen. When the glacier melted away and it was deposited on the plain, within a few thousand years it was collected up by some druids who put it in a burial mound. And there, from that burial mound, it was excavated by Duke or the Cohor or the Cunnington or the Parkers or whoever. Duke was adamant in his correspondence with Cohor, anything that was found in the burial ground, the tombs on his property was his, it belonged to him. So if it was excavated during the time of Duke, Duke took it to his house and kept it. It was when Duke left that Lovibond probably put it on the steppe. Who actually recognized it as a meteorite? Could have been any of these people, but we certainly knew Lodge could have done, who was friends with all of them. And the meteorite stayed there until it was brought to the NHM in 1991, and it was loaned to us in 2011 when we started trying to understand the story of Grandfather's Stone. I end with a prediction here that if this one meteorite survives on Salisbury Plain because it was deposited from a glacier, there may be other meteorites on Salisbury Plain for us to collect And there may be some very interesting Martian meteorites, lunar meteorites, or meteorites of whatever denomination you care to mention. These two meteorites I've talked about, Danebury and Lake House, have never ever been displayed to anybody, and our intention is, as a result of this lecture, in a couple of weeks' time, the curator here is going to make a small exhibition and put out those meteorites within the Royal Society for people to look at. And that's about the end of the story, except to show a cartoon from my friend Matt. If you didn't like stories about meteorites, then I'm sorry, but meteorites fascinate me, and I love talking about them. So I'll be happy to answer any questions. Thank you.
So, well, thank you very much. You've clearly earned your cheque and medal. So there's an opportunity for you to ask a few questions. If you do ask a question, please can you stand up? Otherwise, you will not be seen by our internet viewers. So, and please ask some questions. So there's one there.
You mentioned a couple of meteorites are of Martian origin. How do we actually know where they originate from?
Well, this is another one of the reasons I like science. It's like being a detective. I would have liked to have been a forensic scientist as well as study meteorites. It's a beautiful story. The meteorite 79001 has some little pockets of glass in it. In that glass is trapped some gas. If you release that gas and measure the composition of it, then you can match it on a one-to-one relationship with the atmosphere of Mars as measured by NASA's Viking spacecraft in 1976. Having identified one meteorite as having a Martian atmosphere trapped in it, i.e. that meteorite is Martian, you can relate another dozen or so meteorites to that one by measuring the isotopes of oxygen in the silicates. And we now know, after this work was done in the 1980s, we now know we have nearly 50 Martian meteorites, with the more recent ones being collected from the places in the Sahara Desert.
I was lucky enough to go and visit the Hoeber meteorite in Namibia, which really dwarfs Grandfather Stone. It's enormous. I sat in the middle of it. I don't know the story of it. What's the story of it, and what effect would a meteorite that large have had on the surrounding area?
Well, the Hoeber meteorite is a well-known iron meteorite. Huge matches of iron like that find it more easy to survive than the ones made of silicate, like the ones I've just been talking about. Perhaps the most famous iron meteorite that you could visit is the one that landed in Arizona and caused what is known as Meteor Crater, which was, for a long time, nobody would accept that was caused by a meteorite. There were people who investigated it, thought that they would eventually find so much iron there that it would be a commercial proposition to mine it. They were talking about, thousands and millions and millions and millions of tons of iron. I think Hoeber was about 50 tons, something like that. Of course, there's another very big iron meteorite that you can see in New York, which was brought off the Arctic ice sheet in the early 1900s by the explorer Peary. So iron meteorites they're a small fraction of the meteorite population, but they're usually very big and they don't get broken up during the impacts, so they're more frequent to find them quite big. And so you're very lucky to have visited Hoeber. I hope you enjoyed it very much.
You mentioned the Beagle Project, so what I'd like to ask you is what precautions, if any, were taken following the failure of the Viking lander to detect organic molecules, to prevent contamination of the Martian surface by terrestrial organisms. What's the position about that?
Beagle was launched in order to try and prove that the things that we saw in the meteorites weren't contamination that the meteorites picked up on Earth. So we built Beagle aseptically. Every piece of Beagle that we put together, we sterilized before it was put together, and we built it in a phenomenally sterile clean room. It was a clean room that had you could count the particles in the atmosphere of the clean room, and you could only find one every cubic meter. In fact, it's called planetary protection, protecting another planet from potential contamination by Earth. The planetary protection was actually overseen by a committee of the Royal Society, and the chairman of that committee sat on the row, the other end of the row from you, so you can address your questions to him afterwards. Because we had to satisfy him, we did a good job.
So I think there's one question at the back, and then that must be the last one.
Yes, this relates to the very first question. I'm a bit curious as to the physical mechanism by which something originating on the surface of a planet the size of Mars can escape its gravitational field and arrive in the vicinity of Earth. Nobody's really explained that to me.
Well, you can. It should be a very clear night. You can go outside and look for yourself for the mechanism, because it's a piece of asteroid hitting the surface of another object. And the one I'm referring to is you can go out and look at the moon, which is absolutely peppered with craters. Every time a big chunk of rock hits the surface of another object in the solar system, it causes an amazing explosion, certainly with enough energy to throw off rock that could cross the regions of space to get to Earth. And we know we have 100 lunar meteorites. We can absolutely guarantee they're lunar meteorites because we've got the Apollo rocks to match them to. And we have this 50-odd Martian meteorites. So it's quite clear that impacts which are very violent produce enormous explosions. Certainly can provide enough velocity to get you a sample from another world.
But would not the sample have been overheated during the process, making it difficult to analyze?
It's a part of it would have been vaporized, but there's always going to be a gradation of conditions in any explosion. And so the bits that you actually see are the bits which are at the margins where they weren't destroyed. Fortunately for us, we were able to tell we had Martian meteorites because some parts of the rock 79001 were melted and turned into glass. And as the glass solidified, it trapped the atmosphere of Mars. It gave us this clue to tell us we had Martian meteorites.
So, well, thank you very much. I think that's all we have time for. And so I think you have demonstrated that you're a very worthy person to have joined the group of Faraday Prize winners, and I'm delighted. I should have said I can see at least 2 previous winners sitting in the audience, and there may be more. So can I wish those of you who are watching on the internet, thank you for joining us, and will you all join me now in congratulating Colin on his lecture?